Hello, good morning children. How are you? In last class we have discussed about one of the division regarding the Protista. In Protista, how many divisions are there? Five divisions are there. Out of those five divisions, in the last class I told about the euglenoids. Now the next division of the Protista, that is the fourth division according to our classification and serial number mentioned, that is slime molds. These slime molds are also known as false fungi. Slime molds are also known as false fungi because these organisms develop a slimy mass-like structure. These organisms develop a slimy mass-like structure, and such slimy appears in their cells, hence it is called as a slime mold. So slimy mass-like body is present in these organisms, hence these are known as slime molds, and these slime molds are saprophytic in nature. These slime molds are saprophytic in nature. What does it mean? They grow on decaying twigs and leaves in order to engulf the organic matter from the decaying part. Okay, slime molds are slimy in nature because they develop a slime mass of their body structure. These are of two types. Structurally, slime molds are of two types. One is cellular slime molds and the second one is acellular slime molds. So first one is cellular slime molds. There are two types. Slime molds are of two types. First one is cellular slime molds and second one is acellular slime molds. In cellular slime molds, the body of these organism is, in cellular slime mold, the body of the organism is wall-less. It is wall-less and multinucleated protoplasmic mass is present. This is the cell. This is the slime mold structure where the several wall-less cells are present, and it is a protoplasmic mass-like structure. It is a multinucleated protoplasmic mass. Such multinucleated wall-less protoplasmic mass is known as plasmodium. What does plasmodium means? Plasmodium means a wall-less multinucleate condition. This plasmodium is not that plasmodium where we know to be malaria. That is different. This is the plasmodium, a cellular, we call it as a cellular structure of a slime mold. And another thing, during favorable conditions, these slime molds, they grow profusely, they aggregate and they grow fast, and even they can spread over several feet. During favorable conditions, they aggregated to grow and spread over several feet. And do you know, during unfavorable conditions, they produce fruiting bodies. They produce fruiting bodies, and those fruiting bodies bear spores on it. Those fruiting bodies bear spores on it, and these mass of wall-less protoplasmic cell body is a specific character of the slime molds. Here, every nuclei which is present in this protoplasmic mass is diploid in its nature. So, the plasmodium and the cellular structure of the plasmodium and its nuclei are diploid in its nature. And so let us see the example for that cellular structure is physarum. We call it as a cellular structure. It is physarum. And there are another two examples, diptyostelium and another one is acetostelium, where they will come under cellular structure. They will come under cellular structure. So, acellular and cellular, two types of slime molds are there, and the second one is cellular type of slime molds. What does it mean? In cellular type of slime molds, the body consists of wall-less, many amoeba-like cells. Wall-less, many amoeba-like cells. In cellular type, the body consists of several cells, and these cells are grouped together, but they are not fused. So this is the cellular form, and we call this protoplasmic mass as a cellular form. For this acellular form, example is physarum, and for this a wall-less group of amoeba-like cells is nothing but the cellular structure of slime molds. and these are also known as mixed amoeba or pseudoplasmodium. We call this cellular structure of the slime mold as mixed amoeba or pseudoplasmodium. We call it as pseudoplasmodium. So in these cellular structures, what happens? Their cells are grouped together, but they are not fused. They are not fused. Here, all the nuclei present in a protoplasm, mass in protoplasm. The protoplasmic mass is present. Hence, we call it as multinucleated cytoplasm, and we can also say it as a wall-less xenocytic condition. So here, a cellular condition is a wall-less xenocytic condition. Here, in case of cellular condition, several wall-less cells which appears like amoeba, we call them as mixed amoeba or pseudoplasmodium. And these, let us see here, slime molds are saprophytic protists. What does it mean? Saprophytic protists. They feed on decaying twigs and leaves which fell off from the trees. So such leaves and twigs are decayed and composed into an organic matter. So that organic matter is engulfed by these slime molds. Let us see here. Under suitable conditions, they form an aggregation called plasmodium. Under suitable conditions, they grow rapidly and even they can spread over several feet. Such a structure which is forming from the slime molds under suitable condition is nothing but plasmodium. And let us see here, during unfavorable conditions, plasmodium differentiates and forms fruiting bodies, and these fruiting bodies develop spores on it. These fruiting bodies develop spores on it, and these spores are, see here, fruiting bodies bear spores at their tips. They possess two walls. This is very important. Almost all cellular and acellular structure of the slime molds is wall-less, but the fruiting bodies which are producing the spores, they possess true walls. So spores are having walls, but a cellular condition like plasmodium or cellular condition like group of amoeba cells do not possess the cell wall. See here, they have naked cytoplasm and multinucleated. They are extremely resistant and survive for many years even under adverse conditions. Even extreme temperatures or even adverse conditions or even unfavorable conditions for their growth, they can tolerate and resist for longer time. So these are slime molds. We can say these are slime molds.